This time I would like to do a more complicated example so you can see how the loop rule and junction rule work together to help us solve circuits. Let's say that we have a circuit where we have a battery and then a resistor over here like this, and then another branch with another resistor like so. Alright, and just to keep things consistent, let's say that we have 1.5 volts for the battery. Maybe this will be a 15 ohm resistor and this one will be a 30 ohm resistor. Okay, so the first thing that I'm going to have to do is I'm going to have to give names to some different currents because we have now different currents in different parts of the circuit. So there's some current that goes through here, which I'll call I1. There's some current that goes through this resistor, which I'll call I2. And there's some current that goes this way, which I'll call I3. Okay, so I1 splits at this junction at the top and becomes I2 and I3. And then later, at the junction at the bottom, I2 and I3 are going to come together to make I1 moving back to the battery. Okay, so the first thing that we can do is we can say that I1 is going to be equal to I2 plus I3. That's the junction rule. And you might say, okay, well, what if I don't know which way the currents are all going? If you have a complicated circuit and you aren't sure, it turns out you can just guess. And if you guess wrong, then at the very end of the calculation, a current will come out negative. And that'll tell you that it was just the opposite direction as what you picked. So nothing bad happens. You just have to choose a direction for now, and then later you'll be able to tell if you guessed incorrectly. Okay, so we used the junction rule. Now we need to use the loop rule. And the question then is, what loop do we use? There is more than one loop in this circuit. And the answer is you can actually use any loop you want. So let's say I pick the left loop, which looks like this. Okay, that's a loop. And so if I use the loop rule on that one, well, at the beginning I go up the battery, so I get 1.5 volts. Then as I go across the top of the circuit and then down that resistor, because I'm traveling with the current, I'm going downhill, so that will end up being 1.5 volts minus I2 times 15 ohms. Okay, and that's all the way back to where I started that loop. So those add up to 0. Okay, or I could consider the right-hand loop. So there's a right-hand loop here, so I pick a spot, any spot around the loop, and I go around like this and calculate the loop rule around there. Well, the first thing that I crossed was the resistor in the middle, the resistor that's 15 ohms. But notice this time I'm going backwards opposite the current. So because I'm going opposite the current, I'm going uphill. So this is going to be plus I2 times 15 ohms. Okay, so again, it's just because I'm going against the current. As I follow the loop around, I cross the 30 ohm resistor. This time I'm going with the current, so that'll be minus I3 times 30 ohms. Then I'm back to where I started, so those add up to 0. Okay, but there's actually a third loop. So the third loop is the big one. So if I start here, go around, keep going, all the way around, back this way, that's a third loop. It's a perfectly good loop. There was nothing in the junction rule, there's nothing in the loop rule that said that there couldn't be other branches involved or anything. I just pick any loop and it has to work. Okay, so let's do that one. Well, the first thing I cross is the battery. So I get 1.5 volts going up the battery, then keep going, and then go down the 30 ohm resistor. So negative I3 times 30 ohms, which comes out to 0. Okay, so at this point I have 4 equations in 3 variables. So one of these is redundant. I don't actually need all 4. And that is almost always going to be the case if you have a multiple loop circuit. You will have more choices of junctions and loops than what you need in order to solve the problem. Okay, so we have enough information to solve I2 and I3. So if I solve this equation that I put a star by, then I find that I2 is equal to 0.1 amps. Okay, and then if I solve the last equation, I3, then I get that I3 is equal to 0.05 amps. All right, and then if I use the junction rule equation, then I can see that I1 is equal to 0.15 amps. Okay, so I have found all of the currents everywhere in the circuit by just using the junction rule and the loop rule and then solving. Okay, so notice that any loop at all in the circuit will work. We don't need to pick specific loops. You can choose whatever you want. Just like we didn't have to pick a particular junction, whether we use the one at the top or the one at the bottom will give us the same result. Okay, so how do you approach a general circuit with this technique? So the first thing you have to do is name all the currents. And you also have to assign directions. So typically you do your best to guess which way it'll actually go, but as I said, if you're wrong, nothing bad happens. So you name currents and assign them directions. Okay, and then you write down some expressions for the junction rule. Sorry, you don't have to use every single junction, but you do want to do the junction rule enough times that every current is represented. So you do the junction rule, and then you do the loop rule. Again, you don't have to do every possible loop, but you do want to do enough loops that you have every current represented. And then once you have a bunch of equations from the junction rule and the loop rule, then you solve them. Okay, usually that's the hard part. If you have more than about 3 loops, then this becomes just impossibly complicated. Anyone who's taken linear algebra already will know some strategies for solving equations with, say, 10 variables and 10 equations. But for the rest of you, it's like you can pretty much assume that 3 equations and 3 variables is about the most complicated that you'll have to do. And even that is pretty involved.